Ionic bonding is really very simple. It is the exchange of electrons from one element to another to make both elements have stable shells. I'm going to make an ionic bond between lithium and fluorine. This is very reactive. Here is a model of lithium. It has 3 electrons, 2 in the innermost shell or layer and 1 solitary electron in the next layer or outer shell. Here's a model of fluorine. It has 2 electrons in the first shell and 7 electrons in its outer shell. To make a stable ion, we need to make a noble gas arrangement of electrons. To make this, the ion requires a shell with either 2 electrons in the first shell or 8 electrons in the next shell, and with more complex substances, 8 electrons in the next shell. The fluorine has 7 electrons in its outermost shell. To make this shell more stable, the fluorine requires 1 extra electron to make 8 electrons in its outermost shell. This gives fluorine the electronic configuration of neon. To achieve this, fluorine removes 1 electron from lithium's outer layer, leaving it with a stable inner layer, inner shell of 2 electrons. The lithium now has 1 less electron than its number of protons. This gives an overall charge of 1+. The fluorine atom now has 1 more electron than its number of protons. This makes the fluorine ion negative. We changed the name of fluorine to fluoride to show that it's an ion. I can't give you a reason why the word lithium doesn't change in English to show that it is an ion. The positive lithium ion is attracted to the negative fluoride ion, and so an associative bond is formed. This could be described like 2 magnets that are not physically connected but are still held together, so the resultant molecule of lithium fluoride is formed. The fact that like charges repel and different charges attract mean that large-scale structures can be formed around a molecule like lithium fluoride. The positive lithium ion attracts several negative fluoride ions. So here in the middle we can see a lithium ion, and around it we can see 1, 2, 3, 4 fluoride ions, and 1 at the top and 1 at the bottom. So 6 can just fit around this lithium ion. In the same way, the negative fluoride ion can attract several positive lithium ions. 6 can fit around it. 1, 2, 3, 4 around the edges, and 1 at the bottom, and another 1 at the top. In this way we make a structure like this. The ions are closely packed, but in this model I've made them further apart so that you have an idea of the interaction between the ions. Here you can see the 6 fluoride ions attracted to the lithium ion. We can represent this on paper. I'm going to have a look at a different reaction, and I'm going to have a look at the reaction of sodium with chlorine. I will draw out sodium here with its 2 electrons in the inner shell. It has 8 electrons in its next shell, and in its outermost shell it has 1 electron. Chlorine has 2 electrons in its inner shell, and I'm going to draw these as dots rather than crosses, just so you can see the difference. It has 8 electrons in its next shell, and in its outermost shell it has 7 electrons. Now, chlorine reacts with the sodium. The chlorine takes this electron from the sodium and puts it in its shell. So let's remove this shell here to see the structure of the sodium. The sodium now has a full shell. It has 8 electrons in its outer layer. 8 electrons in its outer layer means that it's lost 1 electron, so it is slightly positive. So we draw this by drawing square brackets around it and putting a plus sign. The chlorine, having gained an extra electron, becomes a chloride ion. It has now 1 more negative charge than the positive charges in the nucleus. So chlorine has become the chloride ion, which is 1 minus. So we represent these ions with the square brackets around them and the plus and minus charges to represent the charge on the ions.